Welcome back. We've got day 5, all about simplifying polynomials. Our goal for today, you will be able to simplify polynomials and use polynomials to represent geometric figures. Okay, to kick us off, let's talk about the different parts of a polynomial. All right, the first part of a polynomial is the leading coefficient. Now, the leading coefficient is the whole number that is in front of the variable, which is your letter, with the highest power. So here our leading coefficient would be 5. Okay, your variable here, we have x's as our variable. Now the degree of the polynomial is going to be the highest power. That's the degree, is going to be the highest power. Okay, and then we have other terms. So these are all terms of a polynomial. This last number here is called the constant. Okay, it does not have a variable with it. It is just the constant number that you're going to be adding or subtracting. All right, so let's go ahead and let's try a couple problems here. So our first example, an expression of the 5th degree is written with a leading coefficient of 7 and a constant of 6. Which expression is correctly written for these conditions? Okay, so let's go back and reread it again. An expression of the 5th degree, so the degree is the highest power, so this is going to be x to the 5th power, is written with a leading coefficient of 7, so 7 goes in front of it, and a constant of 6, so 6 is going to be added to it. So let's see which one of these matches what we have, maybe with another term in the middle. So let's take a look. 7x to the 5th. Here we go, and then adding a 6 constant. So the answer here would be 4. Okay, let's go ahead then and try number 2. Write an algebraic expression that has 3 terms. So 1, 2, 3. The expression is of the 4th degree. So 4th degree means the highest power is going to be 4, with a leading coefficient of 5. Here we go. The constant is negative 6 minus 6. And another term has a power of 2 and a coefficient of positive 3. So a power of 2 and a coefficient, the number in front of the variable, that's how we know there's a variable because coefficient comes before, of positive 3. And now we've written our polynomial. All right, so let's go ahead and let's take a look at simplifying our algebraic expressions. So a couple of vocabulary terms. Remember, like terms are terms with the same variable and powers. A monomial is an algebraic expression with only one term. For example, 7x squared y to the 3rd. This would be a monomial because there's only one term. There's no addition and subtraction. A polynomial is any algebraic expression with more than 2 terms. A binomial has 2 terms, and a trinomial is a special polynomial that has 3 terms. So let's go ahead and try a few. So here we're going to simplify and state the type of polynomial. So let's see. The first thing I want to do is rid the fraction. So here I have a negative negative. So really, I'm going to cross it out and make it a positive, and that gets rid of the parentheses. Now I can combine my like terms. So here I have 8x squared minus x squared. We always want to write the highest power first, so I'm going to add those together and give 7x squared. Now I'm going to look for my x's to the first power. So that's going to be, we just found positive 3x, positive 2x. So that gives me a positive 5x. And then we have a 2 minus 9, which gives us negative 7. Okay, and now if I look carefully, there's 1, 2, 3 terms. So this would be a trinomial. Okay, I'm going to have you pause the video now, and I'm going to have you try number 2 on your own. All right, let's go ahead and take a look. So when you distribute the negative 3, all right, we get that. And then when you combine your like terms, we get 3x plus 14y. Since there's 2 terms, it is a binomial. All right, let's flip it over and try one more where we're going to be simplifying. So here we go. Number 3. If the difference of the first quantity minus the second quantity is multiplied by 1/4 x squared, what is the result? Write in standard form. Okay, so it says if the difference is multiplied, that means we need to subtract first and we multiply last. So if we're going to subtract, the first thing we have to do is distribute the negative to everything. So the first term is going to stay the same, 5x squared minus 3x plus 4 minus x squared plus 5x. Oops, that's going to be minus 5x. We distribute the negative, so instead of a positive 5x, it's a minus 5x. And then a negative times a negative 2 becomes a positive 2. Okay, now I'm going to go ahead and combine my like terms. So here we're going to go ahead, we have 5x squared minus x squared gives us 4x squared. Negative 3x minus 5x is going to give us negative 8x. And then 4 plus 2 gives me a positive 6. Okay, now that we found the difference, now we have to multiply this by 1/4 x squared. So I'm going to put parentheses around it, and I'm going to go 1/4 x squared. Now we're going to have to distribute. So 1/4 x squared times 4x squared. Okay, this is going to be equal to, well, 1/4 times 4 is going to give me a positive 1. And then x squared times x squared. Remember, when you multiply, you add the powers. So 2 plus 2 is 4. Now, just a reminder, in your calculators, a fraction is just a division. So 1 divided by 4. And then I would go times 4, and that's how I would get my product. Okay, now let's go ahead and distribute to the second one. So 1/4 times negative 8 is actually negative 2. X squared times x to the 1 gives us x to the 3rd. And then 1/4 times 6. So let's go ahead and try that. 1 divided by 4 times 6. We're going to get 1.5. Since it is a rational decimal, we can go ahead and write it out. So plus 1.5. Now x squared, there's no x there, so it just stays the same, x squared. And with that, we've got our solution. Now standard form means highest power, lowest power. Okay, second part of today's goal was to be able to use polynomials to represent our geometric shapes. So let's take a look at 3 different word problems. So number 4, in a rectangle, the length is represented by 2x minus 6, and the width is represented by 3x plus 2. If the perimeter of the rectangle equals 52 over 3, find the value of x. Leave your answer in simplest fraction. All right, whenever we talk about a shape, we're going to remember, when in doubt, draw it out. So here we are talking about a rectangle, so let's go ahead and let's draw ourselves a rectangle. Now let's put in all the information that we know. The length is represented by 2x minus 6. So I'm going to give that to the top and to the bottom. And the width is represented by 3x plus 2. Okay, if the perimeter of the rectangle equals 52 over 3, find the value of x. All right, so here we go. So our key word here is perimeter. That's going to help us set up an equation to solve for x. So we need to think, well, what does perimeter mean? It means we're going to add all the sides and set it equal to the perimeter. Okay, so perimeter equals add all the sides. So in this case, our perimeter is 52 over 3. So I'm going to go 52 over 3. I'm going to replace the p with that. Equals, now let's add all the sides. So let's add all the x's. So 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. So we're going to get 10x. Now we're going to add the constants. Negative 6 plus 2 is negative 4, plus negative 6 is negative 10, plus 2 gives me negative 8, minus 8. Okay, so now we have to solve our equation. So I'm going to go ahead, I'm going to add 8. Now, we know we have a whole number in a fraction, so I'm going to let the calculator do the work here. 52 divided by 3 plus 8. And then I'm going to hit enter. Now I am going to get a rational number. It's a repeating decimal. That's okay. So I'm going to just write that down. 25.3 repeating equals 10x. Now I'm going to divide by 10, divide by 10. Now in the calculator, all I'm going to do is hit the division symbol. It takes that whole answer, puts it there. I'm going to divide by 10, and now we have our answer. So x equals 2.53 repeating. However, it asks us to not leave it as a decimal, but to leave it in simplest fraction form. So what I'm going to do now is I'm going to hit Math. Choice 1 is fraction. So it takes that answer and it's going to turn it back into a fraction. I hit enter, and here we go. So x is equal to 38 all over 15. Okay, and we've solved for the value of x. All right, next up, number 5. In a rectangle, the width can be represented by 6x minus 15, and the length can be represented by 4x plus 11. If the rectangle is actually a square, find the length of each side. Okay, before we do anything, remember, when in doubt, draw it out. All right, so we want to draw this out. So let's draw it out. Okay, the width is 6x minus 15. And the length is 4x plus 11. Now, we want to find the length of each side, which means we need to find the value of x. So that's going to be our plan of action. Let's find the value of x. So let's see if there's something in the problem that'll help us do that. If the rectangle is actually a square, so let's think about this. If this is a square, what do you know about a square? Well, it has all 90-degree angles, and all of the sides are exactly the same. So all the sides are equal or congruent. So let's think, how can we set up an equation now? Well, I can set these equal to each other. So 6x minus 15 equals 4x plus 11. Let's go ahead now and we can solve for x. Minus 4x minus 4x. 2x minus 15 equals 11. We're going to add 15 to both sides. So 2x is equal to 26. Divide by 2. And x equals 13. Okay, but the question didn't ask us for the value of x. The question asked us for the length of each side. So let's go ahead and we're going to take the x and we're going to plug it in. So 6 times 13 minus 15 equals, and we can let the calculator do the work for us. So 6 times 13 minus 15. Remember, whenever you substitute it in, you're going to use parentheses, and we get 63. Let's just double check it on the other side. So let's make sure we did it right. 4 times 13 plus 11. Now, if this is indeed a square, these should turn out to be the same. 4 times 13 plus 11, we also get 63. So each side is 63. And we've got it. All right, last question. Let's take a look here. Use the figure to the right to write an expression to represent the following. So what is the length? So let's take a look. So I'm going to call this the length here. Well, the length goes all the way across. So it's A, X, and A. So really that means the whole length is going to be A plus X, which really we can combine those two A's to get 2A plus X. Now let's take a look at the width. Okay, let's add them up. So here again we have A, X, and A plus X plus A, and we can simplify that to give us again 2A plus X. All right, so now to find the perimeter, I'm going to have you go ahead, find the perimeter, and plug it into the computer. Let's take a look and see how you did. So we add up all 4 sides to get 8A plus 4X. All right, nice job, everybody.